Welcome to our journey into the world of logical operators. Logical operators are the building blocks of reasoning, both in mathematics and computer science. They help us make decisions, solve problems, and understand complex systems. In this video, we'll explore what logical operators are, why they matter, and how they shape the way we think. Whether you're a student, professional, or just curious about logic, you'll find these concepts useful in everyday life. Let's start by understanding the basics and see how logic forms the foundation of clear thinking. Logical operators are special symbols or words used to connect statements and determine their truth values. They allow us to combine simple statements into more complex ones, making it easier to analyze and draw conclusions. In everyday language, we use logical operators without even realizing it. For example, when you say, "I will go to the park if it is sunny and I have free time," you're using logical operators to connect condition. Let's dive deeper into the most common logical operators and see how they work. The AND operator is one of the most fundamental logical operators. It connects two statements and returns true only if both statements are true. In logic, it's often represented by the symbol or the word AND. For example, if you say, "It is raining and it is cold," both conditions must be true for the whole statement to be true. If either part is false, the entire statement becomes false. This operator is widely used in computer programming, mathematics, and everyday decision-making. See the AND operator in action with a simple example. Imagine you want to go for a walk, but only if it's sunny and you have finished your homework. If both conditions are true, you go for a walk. If either it's not sunny or your homework isn't done, you stay home. This kind of logical thinking helps us make clear decisions based on multiple requirements. The AND operator is essential in filtering data, setting rules, and building logical systems. Next, let's talk about the OR operator. This operator connects two statements and returns true if at least one of the statements is true. In logic, it's represented by the symbol or the word OR. For example, "I will have tea or coffee" means you're happy with either option. The OR operator is useful when you want to allow multiple possibilities. It's commonly used in programming, searching, and everyday choices where more than one outcome is acceptable. Let's look at how the OR operator works in practice. Suppose you're deciding what to do on the weekend. You might say, "I will go hiking or watch a movie." If you do either activity, your statement is true. The OR operator is especially helpful when you have several acceptable options and want to keep your choices open. It's a flexible tool for making decisions and solving problems where more than one solution is possible. NOT operator is another key logical operator. It takes a single statement and reverses its truth value. In logic, it's represented by the symbol not sign or the word not. For example, if the statement "it is raining" is true, then not "it is raining" is false. The not operator is useful for expressing the opposite of a condition. It's widely used in programming, mathematics, and logical reasoning to exclude possibilities or set boundaries. See how the NOT operator works with a simple example. Imagine you're checking if a store is open. If the statement "the store is open" is true, then not "the store is open" means the store is closed. The not operator helps us define what we don't want or what isn't allowed. It's a powerful tool for setting rules, creating filters, and ensuring clarity in our logic. Logical operators can be combined to create more complex statements. For example, you might use AND, OR, and NOT together to set detailed conditions. In programming, this is common when filtering data or making decisions. For instance, "I will go out if it is sunny and not raining." Combining operators allows us to express nuanced ideas and handle multiple requirements at once. This is the foundation of advanced logical thinking. Truth tables are a helpful way to visualize how logical operators work. They show all possible combinations of truth values for given statements and the resulting outcome. For example, a truth table for the AND operator lists all combinations of true and false for two statements and shows when the result is true. Truth tables are essential tools in logic, mathematics, and computer science for analyzing and verifying logical expression. Let's look at the truth table for the AND operator. If both statements are true, the result is true. If either or both are false, the result is false. This simple table helps us see exactly how the AND operator behaves in every situation. Understanding truth tables is key to mastering logical operators and applying them correctly in problem solving. Now let's examine the truth table for the OR operator. Here, the result is true if at least one statement is true. Only when both statements are false does the result become false. This table makes it easy to understand how the OR operator allows for flexibility in logical expressions and decision-making. The truth table for the NOT operator is straightforward. It simply reverses the truth value of a single statement. If the statement is true, NOT makes it false. If it's false, NOT makes it true. This operator is essential for expressing the opposite of a condition and is widely used in logical reasoning and programming. Logical operators aren't just for math or computers, they're everywhere in daily life. For example, when planning your day, you might think, "I'll go shopping if I have money and the store is open." Or, "I'll eat out or cook at home." These decisions rely on logical operators to weigh options and make choices. Recognizing logical operators in your thinking can help you make better, more rational decisions. Computer programming, logical operators are used to control the flow of programs. They help computers make decisions, repeat actions, and process data. For example, a program might check if a user is logged in and has permission before allowing access. Logical operators are at the heart of algorithms, making them essential for anyone learning to code or work with technology. Logical operators play a crucial role in mathematics, especially in proofs and problem solving. Mathematicians use AND, OR, and NOT to connect statements, build arguments, and verify results. Understanding logical operators helps you follow mathematical reasoning and construct your own proofs with confidence. We use logical operators all the time without realizing it. For example, when deciding what to wear, you might think, I'll wear a jacket if it's cold or raining, or I won't go out if I'm tired. These everyday decisions are based on logical operators, helping us navigate choices and consequences efficiently. Scientists use logical operators to form hypotheses, design experiments, and analyze results. For example, a scientist might say, the reaction will occur if the temperature is high and the pressure is low. Logical operators help ensure that scientific reasoning is precise and conclusions are based on clear evidence. Legal reasoning often relies on logical operators. Lawyers and judges use and, or, and not to interpret laws, build arguments, and reach verdicts. For example, a law might state, a person is guilty if they committed the act and had intent. Understanding logical operators is key to analyzing legal texts and making sound judgments. Business decisions often involve logical operators. For example, a manager might decide, we will launch the product if the market is ready and we have enough resources. Logical operators help businesses set clear criteria, evaluate risks, and make informed choices. Mastering logical thinking can lead to better strategies and outcomes. Effective communication often depends on logical operators. When explaining ideas, we use and, or, and not to clarify our points and avoid misunderstandings. For example, you can have cake or ice cream, but not both. Logical operators help us express ourselves clearly and ensure our messages are understood. Technology relies heavily on logical operators. From search engines to smart devices, logical operators help process information, filter results, and automate tasks. For example, searching for cats and dogs online will show results containing both. Logical operators make technology smarter and more efficient. Games often use logical operators to create rules and challenges. For example, a game might require you to collect a key and defeat a boss to advance, or might allow you to choose different paths. Understanding logical operators can help you solve puzzles and improve your gameplay strategy. Problem solving often involves breaking down complex issues into smaller parts using logical operators. By connecting conditions with and, or, and not, you can systematically analyze problems and find solutions. Logical thinking is a valuable skill for tackling challenges in any field. Artificial intelligence systems use logical operators to process information, make decisions, and learn from data. For example, an AI might decide, if the user clicks and the item is in stock, process the order. Logical operators are fundamental to building intelligent systems that can reason and adapt. Search engines use logical operators to refine results. When you search for cats and dogs, you get pages with both. Using OR broadens your search while not excludes unwanted results. Mastering logical operators can help you find information faster and more accurately online. Databases use logical operators to filter and retrieve data. For example, a query might ask for all records where age, 18, and status equals active. Logical operators make it possible to search, sort, and manage large amounts of information quickly and accurately. Networking protocols use logical operators to determine how data is sent and received. For example, a router might forward data if the destination is reachable and the network is secure. Logical operators help ensure that communication is reliable and efficient. Security systems use logical operators to set rules and detect threats. For example, access might be granted if a user is authenticated and their device is trusted. Logical operators help protect data and ensure that only authorized actions are allowed. Automation systems rely on logical operators to perform tasks automatically. For example, a smart home might turn on lights if it's dark or someone enters the room. Logical operators make automation smarter and more responsive to different conditions. Robots use logical operators to make decisions and interact with their environment. For example, a robot might move forward if the path is clear and the battery is charged. Logical operators help robots act intelligently and adapt to changing situations. Electronic circuits use logical operators to control signals and perform calculations. And, or, and not gates are basic building blocks of digital electronics. Understanding logical operators is essential for designing and troubleshooting electronic systems. Algorithms use logical operators to make decisions and repeat actions. For example, a sorting algorithm might check if one number is greater than another and if a swap is needed. Logical operators are at the core of efficient and effective algorithms. Spreadsheets use logical operators in formulas to analyze data. For example, you might use if statements with and, or, and not to filter results or highlight important information. Logical operators make spreadsheets powerful tools for organizing and understanding data. Social media platforms use logical operators to filter content and personalize feeds. For example, you might see posts if you follow a user or like similar topics. Logical operators help deliver relevant content and improve user experience. Marketers use logical operators to target audiences and design campaigns. For example, an ad might be shown if a user is in a certain location and interested in a product. Logical operators help create effective marketing strategies and reach the right people. Financial systems use logical operators to process transactions and assess risks. For example, a loan might be approved if the applicant meets income and credit requirements. Logical operators help ensure fair and accurate financial decisions. Healthcare systems use logical operators to diagnose conditions and recommend treatments. For example, a diagnosis might require symptoms A and B, but not C. Logical operators help doctors make accurate decisions and provide better care. Teachers use logical operators to design lessons and assess student understanding. For example, a test might require students to answer all questions correctly and submit on time. Logical operators help set clear expectations and measure progress. Project managers use logical operators to plan tasks and allocate resources. For example, a task might start if the previous one is complete and resources are available. Logical operators help keep projects on track and ensure goals are met efficiently. Scheduling systems use logical operators to coordinate events and avoid conflicts. For example, a meeting might be scheduled if all participants are available and the room is free. Logical operators make scheduling more efficient and reduce errors. Logistics systems use logical operators to optimize routes and manage deliveries. For example, a delivery might be made if the address is correct and the package is ready. Logical operators help ensure that logistics runs smoothly and efficiently. Customer service systems use logical operators to route inquiries and provide support. For example, a request might be handled if it's urgent or from a VIP customer. Logical operators help prioritize tasks and improve customer satisfaction. Logical operators can help you make better personal decisions. For example, you might decide, I'll buy a new phone if it's on sale and I have enough money. Using logical thinking can help you weigh options, avoid mistakes, and achieve your goals. Logical operators are everywhere, from computers to daily life. Mastering and not helps you think clearly, solve problems, and make better decisions. Whether you're working with technology, studying math, or planning your day, logical operators are powerful tools. Keep practicing logical thinking and you'll find it easier to analyze situations and reach sound conclusions. Thanks for joining us on this journey into the world of logic.